Hello everyone, welcome to the second video, which is covering the off delay timer. The off delay timer is going to begin timing when the input condition rung goes from true to false. So this is from our first video, which was covering the on delay timer. So please check the first video before you start watching this video. That way you will understand where we have left in this course so far. So here, what we need to do here first is, since we are in the remote run, we are going to go offline. Do we need to change the changes, save the changes? We don't need to at the moment. We didn't do much other than toggling the bit at the moment. So we have timer on delay, and then we are going to change this one to timer of delay. As you can see, it changed automatically to timer of delay. And then here are our EN bit, TT bit, and DN bit, which we have established in the first video, if you remember. And then here is our output, output column 0-0. This is output column 0-1. And then here is we have output column 0-2. And then it's going to represent our green light, yellow light, and red light. So what we need to do here is, first, let's save as this one as our on the desktop. So since we have saved it, we have verified the projects. Actually, let's save it properly. Here, save as. Okay. Now we can close it. In the emulator, if you remember, we were running our on delay timer example. See, we put this in hold, we close it. Now we open our example here. So we choose our station number 1. Then we went back to our desktop and then choose our file name TOF example, which is off delay timer. So here we are going to active. So here is not running yet. So we are going to go online from the comps button here, who active go online. We wait, and then we need to choose MicroLogix 1100, which we have established in the previously. So we click OK. Now we are in remote programming. Since everything is established, we can easily go run. Are you sure you want to change processor mode to run? Click yes. So our accumulating value is right now in 6000. If you remember from the previous example, we have set our preset value to 6000 bit, and our time base was 0.01 second, which means that our preset value in terms of seconds will be 6000 times 0.01, which is 60 seconds. You can change this base to different numbers. Maybe not while we are running, but in the remote programming, you can edit that value as well to 1 second or 1/1000th of a second as well. But right now we have left this time base as 0.01 second for each bit, and then we set the number of bits is 6000, so it is 60 seconds here. So what we are going to do here is, let's see. So okay. So once we toggle the bit, as you can see, right now this is true. So our off timer of delay is true. So if you are coming back here in our file of delay timer, this is true, and the PLC is going to write the ACC value as 0, and then our TT is 0, since we are not timing anything because our value is true. And EN is going to be 1, and then DN is also going to be 1. As you can see, this is 1, and then this is 1. So once we close this switch number 1, this timer will start counting. So as you can see, it starts. So our condition is right now is off, which is false, and then our accumulating value is smaller than our preset value. So we are in false, and the accumulated value is smaller than preset value, which means that our EN bit will be 0, our TT bit and DN bit will be 1. Our EN bit is 0, our TT and DN bit is 1 and 1. So what we need to wait here is when this false, the switch 1 is false, and accumulated value is reach the preset value, our PLC is going to write 0 to our EN bit, TT bit, and DN bit here. So let's wait and see if this is true. We have written out in our PDF file. If not, we will see. So as you can see, our accumulated value reach our preset value. Our switch 1 is false. Our EN bit, TT bit, and DN bit is also become 0. You can also open your table here. You can see the 0 in EN, TT is 0, and DN is 0. What we can do, okay, so as you can see, we toggle the bit, and the switch 1 is on, which is true, and then our timer is true. So our accumulated value becomes 0 again. Our TT is 0 as well, since we are not timing anything at the moment. That's why the TT bit is 0. So our DN bit and EN bit is 1. We can also verify this information for our timer table. EN bit is 1, DN bit is 1, TT bit is 0. Once, if we can actually do that, let's see. If you toggle the bit here, our EN bit is 0, TT bit is 1, and DN bit is 1, and you can see sometimes it's hard to click here. So our accumulated value is trying to reach the 60 second we have defined at the beginning of the program. So let's wait, and then what's going to happen in this table is the TT bit and DN bit will turn 0 as soon as we reach the accumulated value with the preset value, and then since this is also false, these are all going to be 0. So let's wait. We have 20 seconds left. So we have 5 seconds left. 4, 3, 2, 1. And then as you can see, TT bit and DN bit turn 0. So I hope this all makes sense. So this is all we have for this timer off delay functionality in the timers in our PLC. So in the next video, I will cover the retentive timer, what we call the RTO here. And then you will see this is a little bit different than what we have here. We will need to add a reset value to reset our accumulated value. Normally, if you open this one, as you can see, that becomes 0. But in retentive timer, this is not going to be the case. So we will need to add the reset instruction to trigger this resetting functionality in our timer here. So see you all in the next video.